Hi, today I'm going to be talking about topic 8, which is talking about lines and plotting points and equations of lines. So, topic 8, let's just call it lines. I know it says linear functions in the syllabus, and we're getting to that. That's really the broader context of this, but we need to start with really understanding lines. We're going to start with the Cartesian coordinate system. I know that a lot of you know all this stuff already, but I don't want to assume that because I think some people have not seen it or haven't seen it for a very long time. So we're going to sort of start with the basics. If we take a number line, and we're going to call it X, and we are going to take a second number line and call it Y. These are going to be our X and Y axes. We're going to intersect them at 0. So for the y-axis, positive numbers going up to infinity are above the 0, and negative numbers go below. And the number line on the x-axis is just like we were doing in topic 7 for inequalities. We're going to go from negative infinity on the left to positive infinity on the right. Now, if we have this point 0, by the way, we call the origin. It's the point 0 on both axes. And it's actually, some people just call it the 0, but we actually refer to it as the point 0, 0. And I'll explain that because if we want to plot a point, let's say I have a point here, and I'm going to call it, let's say, what do I call that point? Well, let me just hold off on that. That point, the way we refer to its location and where it is on the plane is how far over it is on the x-axis. Let's say it's some number a, and how high or low it is on the y-axis. Let's say that's some height b. So we come over a, and we're up here getting to b, and together we identify that point by the numbers a, b, which we call the ordered pair. Pair. The reason why we call it an ordered pair, let me see if I can get this a little straighter here, is that the order matters. So the first number we put in parentheses, and the first number, comma, the second number. The first number is always referring to the x-axis, and the second number is always referring to the y-axis. Now, in addition, when you're graphing, there's some terminology that is frequently used. If you think of the Cartesian coordinate system, the xy plane, it's dividing everything up into 4 regions. And we number them starting with the upper right quadrant. So these are 4 quadrants. And we traditionally refer to them using Roman numerals. So 1, 2, 3, and 4. And if you think about the characteristics of the points in each of these quadrants, in the first quadrant, the x-coordinate is always positive, and the y-coordinate being above 0 is also positive. So all the numbers that are in the first quadrant are positive, positive. In the second quadrant, we are now to the left of 0, of the origin, so the x-coordinate is negative. And the y-coordinate, because we're above 0, is positive. In the third coordinate, we're to the left of 0 and below the axes, like down below here, below the x-axis. So here, the y values are all negative. So we're negative on the x and negative on the y. And in the fourth quadrant, we are now back over here on the positive values of the x-coordinate, but we're negative on the y. So we're positive and then negative. So therefore, you can see that each quadrant has distinct characteristics for the positives and negatives. All right, so now let's talk about actually plotting lines. So graphing lines. So we're going to start with 2 points, and actually any 2 points will define a line. Okay, so let's take, we're going to just make an XY axis, and I'm going to pick a point. Let's say I want to go with the point -3 on the X and +2 on the Y. So this is the point, I'm going to call it A, and it's the ordered pair -3, 2. So we can refer to points by giving them names, like this one I called A, or we can identify them using their ordered pair. I'm going to put a second one in, and let's say I call that one B, and it's going to be at 4, 5. So I come over here to 4, and then I'm going to go up to 5. So 4 and then up to 5 puts me here. So this is B, which is 4, 5. Once I've done that, then I can draw a line connecting these points. And I have drawn a line. The shortest distance between any 2 points is a line, so you can remember that if you're walking around campus. Now, lines have also a concept of slope. So, concept of slope. Or you can think of the slope as the incline, which is a number that is describing how much incline a line has. So obviously when you're walking around, if you're going up a hill, it has a higher incline, or if you're going down a hill, it has a lower incline. So let's talk about how that gets translated over mathematically. And I have a really nasty, messy erasing situation going on here. So hopefully it won't be too bad. All right, so when we're talking about slopes, let's just take the XY plane, and imagine now that I have a line on here. And I'm going to go ahead, and it doesn't have to go through the origin. I'm going to just pick a point here, and I'm going to put a line through it. So now let's take this line. Now imagine that this line is made out of something very solid, like it's made out of like a dowel, like made out of wood, right? Now notice as we read this, remember this is the x-axis and the numbers get bigger as we go from left to right. So as you read this from going from left to right, so it's going up. So reading from left to right, going up means it's increasing. So as you're reading from left to right, and it's increasing. So that's one type of slope you can have. All right. Now, if I push this up so that my down now, I move it up and I go this way. All right. Actually, let me just make sure let me back up a second. So this line, we were going to give it a number, and I'm going to talk about how we figure out what that number is in a minute. So let's just first understand that the amount of incline is going to give some number, m, which is going to be the slope. Okay, now if I increase the incline, okay, oh, by the way, if this is an increasing slope here on this line, that slope is positive. So m is greater than 0 is positive when it's an increasing line. An increasing slope. As I go higher up, as I push, let's just say I put a bolt through this spot and I start sliding this up on this end. As that increased slope, this slope here, the slope on these lines is increasing. So I'm getting bigger and bigger numbers on my slope, the number that's characterizing how much incline. So as this line tilts up, it's going higher and higher. Now, think about now going the other way. If I take that, rod and I start pulling it down so that now it's coming down this way, okay, now as I read from right to left, this is going down as I go from right to left, so we say that this is decreasing. And when a line is decreasing, it has a negative slope. So m is less than 0, negative. Right? And then again, as that line becomes more and more negative, the slope gets more and more negative. So let's just say this slope here was negative 5. Then as we go to this one may be negative 20. It's just a number that's more negative, describing the quantity of slope that we have in this line. Now, as we go here from the positive slope, as I take that rod and I bring it down and I start pulling that rod down, it's going to get to some point here where it's just totally flat. Right? So let's just say this line right here, that's totally flat. Above that, the rod had a positive slope up here. I start turning it, pulling it down, it has to become totally flat before it becomes negative. When it's totally flat, these numbers go from positive above to negative below. So this slope is 0. The horizontal line in between the positive, as I pull that down, goes to 0 and then becomes negative. Now, this is what we call a horizontal line, right? So this is a horizontal line. And it has a 0 slope. 0 is a number. It means it's flat. It's flat. Right? We all like to walk on flat ground, usually. Okay. Now, in addition now, what happens if I take that rod and I keep pulling it up and up and up, and that number, that slope keeps going higher and higher and higher? Well, eventually, that rod's going to sit right on top of the y-axis, right? And it's straight up and down. And this is a vertical line. And you can think of this slope as being like positive infinity, which is not a number. Or if I come down this way and I turn it this way, it's like heading towards negative infinity before it becomes vertical. So in both cases, the slope is not a number. It's not defined. So vertical lines, the m is DNE, does not exist for a vertical line. All right. Now, I'm going to talk about slope more, but I think that this is getting messy here. Let's see. I'm going to have to erase this. Okay. Let me just clean up this board. I'm going to pause the video. Okay, so picking back up, we were talking about slopes. So let's like just look at an XY coordinate plane. And we have a line here. Let's say this is an increasing slope. And what that means, and I apologize, it's kind of, hopefully you can see that okay. Okay. All right. So what we mean by that is we take any point on that line. To get to another point, we have to go up. So we're going to go up and over. And this amount that we rise versus how far we run. Okay, so we rise and then run. And that gives us an idea of what we mean by the slope on here. So what we're going to do is think about the slope as being that ratio of rise over run. Notice that and again, we're always going to pick a point and move it to the right to help us decide on what is the direction of the slope. So because to go to another point to the right, we have to go up. So So we have positive rise and positive run, right? So when we have positive rise over positive run, this is going to be greater than 0, is how we see that positive slopes correspond with increasing inclines, okay? And if we take another line, I'm just going to make another line here, and this one's decreasing, right? You would say that's like going downhill. You're decreasing, you're sloping down. So again, picking a point, 2 points on the line, to go from one point to the next, you have to go down a certain amount. So the rise is down, right? You could say that's a drop, but we're going to just use the same word. It has negative rise, if you will, and positive run. So we have a positive run this way. Okay, so in this case, when we look at the rise versus the run, it's negative, right? So going back to that situation where we were talking about where we have a horizontal line. So in a horizontal line, let me just draw another quick Cartesian coordinate system here and put in a horizontal line. So here's my little horizontal line, and I'm going to pick a point on that line. And if I'm going to go to the next point, I have no rise, right? So here, remember I told you for the horizontal, the rise, we're going to talk about rise over run. The rise, there's no rise. So the rise is 0. And the run is whatever distance it is to that next point. It's some number, okay? So this is 0. So this is how we can see the horizontal line. It has a 0 slope because we always have 0 rise. Any number in the denominator, it doesn't matter. 0 over any number in the denominator will be 0. Okay, and then the last one that we talked about was if we had a vertical line. So let me draw a vertical line. This is my vertical line. And now if I'm going to put 2 points on this line and think about going from one point to the next, okay, the slope on that, again, thinking about the ratio of rise over run, the rise is some number, right? So we have some number from here to here, whatever that distance is. But what's the run? It has no run. It doesn't go, you don't move left or right. You stay right on top. So the run is 0. And anything divided by 0 is undefined. Or we could say, another way we could say that is that it is does not exist, or DNE. All right, so now let's think about how, now that we understand the concept of what we mean by slope, let's talk about how we actually get our hands on these numbers, these rise and run numbers. Now, the way I drew this is a hint, and that is that you can pick any 2 numbers on a line. They will always give you the same slope, believe it or not, no matter how far apart they are or how close together they are. When you calculate the slope, it's the same for any 2 points on that line. That's one of the characteristics of a line, that it has the same slope between any 2 numbers. So let's think about how we're actually going to calculate that. And again, I have to clean this up. Okay. Sorry about that. My eraser's not working. I'm going to kind of zoom in to 2 points here on the x-axis, and I'm going to, instead of giving them actual numbers now, I'm going to just refer to x1. Whenever I put a subscript, it means it's an actual number. So this is going to be the point, right, the xy coordinates, x1, y1. And we're going to now go to the second point. Let's put this one over here. And again, I'm going to refer to it with the specific numbers x2, y2, meaning I can just pick any two numbers. I don't want to actually say what they are. I'm going to just give them these subscripts to mean I just pick these two numbers. This one's y2. All right. So now when we talk about going from x1, y1 to x2, y2, and we want to talk about the rise, we're talking about this distance right here. That distance is the difference between these two numbers. So you can see that the rise is that distance. And we're going to talk about the rise over the run, and the distance is y2 minus y1. Right? It's that distance right here is y2 minus y1 will give us that distance. And then the run, so hold on, this is the rise. And then the run will be going, once we're here, we're going to go all the way over to here. So that distance is the same distance as, if we look down here, the distance between x2 and x1. So that's x2 minus x1. Because think about it, you come all the way out from the number line x2, and you got to chop off the x1, so you get that distance. So we're going to say that's x2 minus x1. And from there, we have our equation for how we get the number that corresponds with the slope of a line. So let's do an example of that. We're going to sketch the line that passes through minus 2, 5 with slope negative negative 4/3. All right, so let's go first and do an XY. Let's just do a graph of this so we know what we're talking about. Well, we want to sketch the line. But actually, what I meant to say was let's start with the slope. Slope is negative 4/3. Now, it's really important that you're comfortable with the idea that as long as you only have one negative, that negative can go anywhere. So that negative 4/3 is, I can put that negative up on the top and say that's negative 4/3, or I can think of that as 4/-3. Now, when we translate this to what we mean in terms of slope, this one, where we put the negative on the top, means down 4, because that's the rise, so it's a negative rise, right, over a positive run, so right. We always go positive to the right, so right 3. And this one, where we put the negative in the bottom, it translates to up 4 and to the left 3. All right, so let's see how that shows up on a graph. So if I do my graph, and I go over here to negative 2, and I'm going to count by 2's on the y-axis. It's okay to count in different ways on the x and y-axis as long as you label it. So this is going to be 2, 4, this is 6. So the point negative 2, 5 is going to be negative 2, and I'm going to go halfway between the 4 and the 6 is where the 5 is, and I'm going to put a point there. All right, so now I want to do another point on here. So I start by graphing that point, then I use my slope, I use my instructions to find the second point. This one says go down 4 and to the right 3. So I'm at 5 here. I'm going to go down 4 to 1. So I come down 4, so that's the minus 4 part. And I am going to go now right 3. So I'm at negative 2. I'm going to come all the way over here to 1. And I'm going to go 1 over a run of 3. So down 4 and a run of 3. Now, I could have also used this alternative definition. And with this alternative definition, I would go up 4. So I'm at 5, and I'm going to go up to, that's 8. I'm going to say that's 10, so I'm going to go up to 9, right? Because I'm I'm at 5, and I want to go up 4. So I go up 4 to 9. So that's up 4. But now I'm going to go to the left 3. So I'm at minus 2, minus 3, minus, sorry, I'm already at minus 2, minus 3, minus 4, minus 5 over here on the x-axis. And so I am going to come up over here to this point right here. Now notice these points will land on a line, unless I made a math mistake, they will land on this line. And I was able to sketch it using the slope. Okay, and with that, I'm going to pause and clean the board and pick up again. Okay, our next example is going to be looking at, the question is, what is the slope between these 2 points? Two, 3, and -1, 6. Okay, so let's go ahead and graph this. So let's graph our first point as 2, 3. And the second point is -1, 6. So -1, let's say that's 3. This is our y-axis. This is our x-axis. And we are going to go to -1 and up to 6. So -1 on the x-coordinate and 6 on the y-coordinate. Okay, so we have these 2 points. And we'll draw a line between them. Try to draw a straight line, not like me. Okay, and then we see that it's decreasing, right? So if you look at this line, you were walking on it, you'd be going downhill. If you always make that assessment by going from left to right. So this is decreasing. So that means we expect when we do our math that the slope should be negative, right? So n should be negative. Remember, this means negative. So let's do the math on this. We saw that the slope is y2 minus y1 over x2 minus x1. So what I recommend that you do, because it's really easy, I see people flip things around and get them messed up, is go ahead and label these points, x1, y1, and x2, y2. Now it doesn't matter the order. You could do it the other way around, you'd still get the same answer. But we're going to get y2 is the 6, minus, you're going to go over to the other point and get the y from that point, minus the 3. Now this is the really important part. You have to, if you use the 6 first, you have to use the corresponding x as the first number in the denominator. So it's -1 minus 2. All right? So just to be clear on that, what I'm saying is these 2 numbers come from the x2, y2 here, right? And the second 2 numbers have to come from the other point, the x1, y1 point. Right, so now we just do the math. So we have 6 minus 3 is 3, and -1 minus 2 is minus 3. 3 over -3 is -1. Okay, now our slope now is a -1. It doesn't matter how I want to view that. It's really important that I realize that -1 can be written as -1 over +1 or +1 over -1. And the reason I want to go ahead and add that dividing by 1 when I have a whole number slope is to remind myself that the run is 1. So I have a rise of a certain number in the numerator over a run in the denominator. Okay, so that means that on this graph, if I were to start at 6, -1, I can consider this version of the slope, right? This was the slope. Go 1 down and 1 to the right, 1 down and 1 to the right. And that gives me a point on the line. Come down 1 and over 1, it gives me another point on the line. I can also use this version, and I can take a point on that line and go up 1 and over 1. and you'll see we get to the same place, up 1 and over 1, up 1 and to the left 1. Sorry, I meant to say to the left 1 because it's a negative 1 in the denominator. So remember, that's rise over run. So this is down 1 over to the right 1. And that's coming down. Down 1, right 1, down 1, right 1. This is up 1, left 1. So it's up 1, left 1. Up 1, left 1. Up 1, left 1. Okay, hopefully that makes sense to you. All right, the next one is, I'm just going to do a few examples. So let's say our slope is 3. Then that means that could be a 3 over 1 or a negative 3 over negative 1. Right? If we want to know the slope that has, we want to graph the line that has a slope of 3, and goes to the point, let's just say 4, 2. All right, so we're going to draw our XY axis. We come over here to 4, and up to 2. So that's our first point. Now, if I use this version of the slope, that means I'm going to go up 3 and to the right 1. So I'm going to start at that point, and I'm going to go up 3. So I'm at 2. I'm going to go up 3. So 2 plus 3 is going to take me to 5. So I go up 3 from here. And I'm going to go positive 1 to the right. Right? So this one is up 3, right 1. Right 1. So I go there, and I'm going to go over 1 to 5. Or I could use this version of the slope. Remember, a negative over a negative, those negatives cancel, it becomes a positive. So this is just another way to write the positive number 3. And this one we view as down 3, left 1. It's just instructions on where to go. So we started over here at 2. Now we're going to go down 3. So down 3. So I'm at minus 3. That's where we were when we started. Okay, we're going to go down 3, and then we're going to go left 1. So we're at this point, we went down 3 to the left 1, or we went up 3 and to the right 1. And we can connect those 3 points, and they will be on a line. All right, so starting at any point, you can go either up or go down to find another point. Okay. I have to clean my board again. So now that we've talked about lines and how to graph lines, I want to start transferring our lecture tonight over to equations of lines. So let's talk about that. So I want to put this in context. We were talking about solving linear equations before and then solving quadratic equations. So when we talk about solving linear equations, they are connected to lines. And I want to show you that connection today. So first of all, recall that we talked about a standard form for a linear equation. And when I said we wanted to create a standard form for a linear equation, one of the things we said, well, we knew it was linear, right? We always ask that question, is because the highest power is 1 on our x, or whatever the independent variable is. On x is 1. All right, since we're doing the XY graphing now, we're going to tend to have our independent variable be our x. You may get some problems on delta math where they still use W's and P's and Z's and all that, but just conceptually, I want you to think about that. We want the highest power on that independent variable to be an x. And if you recall, we said that it was standard form, and if you could put it into the form of an mx plus b, so you have some number in front of the variable x, right, and then some constant. And we would get 0 on one side. Now, I told you this is not the strategy to solve a linear equation, but it is called the standard form of a linear equation. Okay? Now, what I'm going to do now is we're going to sort of forget about this equals 0 part, and we're just going to talk about this part right here. And let's say this linear equation, I want to call it y. I'm just going to give it a name y, okay? And basically, it's just going to be what happens when I put in a value for x and I crank through this, right? I'm going to get this y. So here we're thinking that, let me rewrite it. Y equals mx plus b. Okay. So here, this is the independent variable. And y, we call the dependent variable. Because it depends on what x is. So whatever value we get for x, and m and b are actual real numbers, right? They're not, we're using them as placeholders for actual real numbers. But we're going to kind of think now that x can be anything, any variable that's in the domain, and y is the result of cranking through this. Now, if you notice, this, right, is a first-degree polynomial. It's a first-degree polynomial. And we want to know, how is this first-degree polynomial that we kept talking about it being a linear equation, and we had all our strategies back in topic 5 for how to solve linear equations. How is this related to a line? And how can we see, we notice that there's an m here, right? I think when I introduced it back in topic 5, we put an a here, but it's just a number. Now I'm calling it an m. Those of you who have maybe seen this not too long ago would know that that's the slope-intercept form of a line. But how do we get this connection? How do we actually see that this is the equation of a line? Well, the way we're going to do that is using the point-slope equation of a line. Okay, so to do that, let's just start out with the formula for a slope that we figured out. We figured out that the slope is y2 minus y1 over x2 minus x1. All right, and we talked about how that all made sense. So now we're going to replace the x2 comma y2, which, remember, this was a specific point, right? This is a specific point. And we're going to replace it with the variables x, y, right? So what that means is if we have a line, let's just draw a line on here, and we have a point on that line, x1, y1, and we know that this line, this line has a slope. Okay, so we have some slope already. Now, I can take a little bead, and I can put a little bead on that line, and I can have it points down to some x. So I point some x, and I can slide my bead up and down this wire. Think of this line as being a wire, and see what it points to. Let's say it has a little laser light, and it points straight over to the y-axis, and it tells me what it's pointing to. And I'm going to let it, whatever this x points to as it slides up and down this wire is going to be the y. So I take my slope equation, and it's, remember I told you any 2 points on that line, if I stick them in the slope equation, they give me that same value of m. That means I can go in here and I can remove that x, and the sub 2 and the sub 2 from the x and the sub 2 from the y, and let that float or slide on this line. All right, so by doing that, I've now come up with this equation, m equals y minus y1 over x minus x1. And all I'm going to do now is what we learned back in topic 3, which was dealing with rational expressions. So I want to get rid of the denominator on both sides. So, I kind of want to make this simpler by removing the fraction. So I'm going to multiply both sides by the denominator. On this side, this is just a disguised form of 1, right? Because if I multiply fractions across, I get x minus x1 over x minus x1, and that's equal to 1. So that goes away. And what I'm left with, and I'm going to flip the order I write it in, I get y minus y1 is equal to m times x minus x1. And this is the point slope equation of a line. All right, so that's the first step. That's like halfway there to seeing what's this connection back here to this y equals mx plus b. So now I'm going to take this equation right here, and I'm going to solve for y. So in order to do that, I'm going to need some more whiteboard. I'm going to clean this up, and I'm going to pause and start again when I have some. Okay, so moving above, we have now, I'm going to put the, try to remember to do this. Y is the variable minus y1, right, equals m times x, which we're also now not being specific about what x it is. It can be any x, x1. Now, I want to kind of, in parallel, remember that previous example, where the previous example we had the point 2, 3, and the point negative 1, 6. And we found out that the slope was negative 1. Remember? We just got done doing that example. So if I say negative 1 equals, the way remember we did it was 6 minus 3 over negative 1 minus 2. And now what we're doing here is we're just going to replace the minus 1 in the 6. This is what we did down here below. We made this into y and x. And then we multiplied both sides, and we ended up with y minus 3, right? Multiplying both sides by x minus 2. That's multiplied through. These cancel. So we get y minus 3. And we get now negative 1 times x minus x1. Okay, so I just wanted to make a parallel to where we're at so you can kind of follow along what we're doing. So the first thing we're going to do is we're going to get rid of the parentheses by distributing the m through. So over here, that means we're going to distribute this negative 1 times these numbers. Sorry, x1 was actually a 2, wasn't it? I meant to do x minus 2. Okay, so we're going to distribute that through so we get negative x, and negative 1 times negative 2 is a positive 2. So now I have y minus 3 equals minus x minus 2. So let's do that over here in the symbolic algebra. We have mx and minus mx1. Now remember, just like negative 1 times negative 2 was a positive 2, this m is a number and this x sub 1 is a specific number. So this is really just a number. Like over here, it turned out to be 2. All right, but this mx part isn't just a number. It's a number times our variable x. And that's why this part has a coefficient in front of the x. Okay, so now we're going to add y1. So let me just bring this down so we have all on one line. We're going to solve for y. We want to keep that in green. We want to solve for y. So we're going to add y1 to both sides, right? So on this side, we'd be adding 3 to both sides. Right, so over here, it's easy, right? We see it's y equals negative x plus 5. So over here, we get that y is now equal to this mx, and this whole thing is all minus mx1 plus y1 is all going to get added together. It's just some number, whatever those specific values are, and they turn out, we're just going to call it b. Whatever it turns out it's going to be, we're going to call it to be that number b. Over here, it turned out to be 5. Okay? So here we see how we made that connection, because now we have, using our slope, we have that y equals mx plus b. We know that that identifies the equation of a line, and this is the the slope intercept. Slope intercept equation of a line. Now, the reason that we call it the slope-intercept equation of a line is because the B right here is the y-intercept. And I'll explain what that means in a second. I just need to clear the board. Okay, actually, the fact that it's the y-intercept is something we can discover later. For now, let's just say it's whatever this minus m times x1 plus y1 turns out to be. It's just some number. We're going to call it b. So let's do an example. We're going to find the equation of a line that passes through 1, 3, and has slope 2. And I'm just going to go ahead and say m equals 2. All right. So there's 2 ways to do this. So we can use the point slope equation of a line, or we can use the slope intercept. So using the point slope equation of a line, we use that m is going to equal y minus y1 over x minus x1. And then we're just going to put in everything we know. So we know that 2 is equal to y minus the 3 over x minus the 1. Multiply both sides by x minus 1. And we get, distributing this 2 here, we get 2x minus 2 is equal to y minus 3, and we can add 3 to both sides. And I can rewrite it right in the other way and get that, I'll just say y, 2x plus 1 here. Or we can use the slope-intercept formula line, which starts with y equals mx plus b. This has to be true for any point on the line, so in particular has to be true for this point, as long as we use that slope. So 3 has to equal 2 times 1, right? So this is our y, and this is our x over here, right? xy plus b. So we have this one unknown b here. We're going to solve for it. So we subtract 2 from both sides, and we get 1 is equal to b. And then we use that b back in the equation here. And actually, we use it back in this equation, substituting in m. So we say y is equal to the 2 that comes from the original problem, x, plus the 1 that we solved for. y equals 2x plus 1. So you see these match up. All right, so you can do either one. You don't have to do both. I usually find that using the slope-intercept form is a little quicker, but some people prefer the point-slope approach. All right, so now let's take this line and see why we call that the y-intercept, okay? So let's graph this line. So I need to clean up some board space. Hoping this is good, save some time here. All right, so let's start out by taking some values for x, and we're going to calculate what the y is. And then from that, we're going to make an x-y pair that we're going to graph. All right? So my y is going to be equal to, according to this, 2x plus 1. So I need a little more space here. Y is equal to 2x plus 1. Probably should have given myself more space here. So let's just go like this and do that. Okay, so let's say I pick a number here. I'm going to pick 0. So if I pick in 0 for x, that means y is equal to 2 times 0 plus 1. Well, that's just 0 plus 1 or 1. So my x, y coordinate is, my ordered pair is 0, 1. So let's go ahead and start graphing this. So we have 0. And let's just go with a few points here. Let's see, that's 1. So our first point is going to be 0, 1. All right. Now let's say I don't want to use my slope, because we know we can graph this by picking other points using the slope and saying, okay, the slope of 2, that's the same as up 2 and over 1, or down 2 and to the left 1, right? I can use this and build new points. But let's say I just want to do something else. So I can pick the number 3. So I can say, well, then y equals 2 times 3 plus 1, and that's 6 plus 1, which is 7. So the point is 3, 7. So I can go over 1, 2, 3. And then I got to go up to 7. 2, 3, 4, 5, 6, 7. So I'm going to go 3, 7 right there. All right? Or I can just pick like a -2. So y equals 2 times -2 plus 1. And that's -4 plus 1, and that's -3. So the point is -2, -3. In other words, y, the height, remember, the height is the y-coordinate, is dependent on what the value of x is. That's why we say y is dependent, x is independent. We pick the x, we calculate the y, and we create an ordered pair. So this one's over here at -2 and -3. So -2 and -3. And we can put a line through these points like that. And we see that we have a positive slope. The line is increasing. We expected to see that. We could have also gotten to each of these points just by using the slope and counting up 2 and over 1, up 2 and over 1, or down 2 and to the left 1 a couple times each way and gotten there. Okay. One really important thing I want to be very clear on is that when you have an ordered pair, x is the location left and right, and y is the height. And what we often care about when we are talking about equations of lines is the height. So it's this y. That is what we care about. So when we come, for example, like a cost function, we put in our number of units. What we really care about is the height, the cost. Or if we think about a revenue function, we may actually care about the actual revenues based on what the x is. And we're going to be talking more about that soon. Okay. So I just want to talk about a couple more types of equations, the horizontal and the vertical ones. So let me clear my board and I'll get back to it. Okay, so for this next equation, we want to find this next example, we want to find the equation of the line that passes through the point 2, 3 and has slope 0. You can also say that this has no slope. Now, no slope means a flat slope or 0 slope. It doesn't mean the slope does not exist. Okay, so no slope means m equals 0. It's kind of like semantics argument. I guess you could say, well, if you say there's no slope, then I guess that slope doesn't exist. Well, that's the wrong interpretation. When people say something has no slope, they tend to mean it's flat. Okay, because as I was showing you about that idea about the rod, really vertical lines, they have no numerical slope, but they're considered to have kind of like an infinite slope. So when we say no slope, we tend to mean m equals 0 or it's flat. Okay, so if we think about the point 2, 3, and with a slope 0, we know it's a horizontal line, and m equals, m equals 0, so it's a horizontal line going through 3, right? We know that m equals 0. It's horizontal. All right, so now let's think about finding the equation of that line. Well, if we use the point slope approach, we could say that we're going to take y minus y1, and that's going to be m times x minus x1, right? So using what we know, we're going to say it's y minus the y, which is the 3, equals the 0 times the x minus the 2. Now 0 times anything is 0. So this is just y minus 3 equals 0. And we're left with, if we add 3 to both sides, that y equals 3. Now notice that makes sense, right? Because it's a horizontal line, y equals 3 is the height. That's the height. X can be anything, right? So when I just say y equals a number, I'm just defining a horizontal line. I'm talking about the height. Right? Now look, you can see the same thing with the slope-intercept approach. Right, remember that one starts out with y equals mx plus b. So here we're going to say 3, which is our y, equals 0 times the 2 plus the b. 0 times 2 is 0, so this is just 3 equals b. So putting that back into our equation, we get y equals 0 times x plus 3. And this again goes away, so it's y equals 3. So we get the same thing. And in the y equals mx plus b form, you can really see we're putting in directly that that slope is 0. It's going to make the whole x variable disappear. That's why there's no x variable when it's a horizontal line. All right. Now the next one I want to talk about is the vertical equation. So let's talk about another example. So this is the equation. We want to find the equation of the line through, I think I picked 4, 3. That is vertical. Well, we're kind of in trouble there, right? Because vertical means m does not exist. So how can we even use anything that we've done up until this point? We're kind of stuck. It's like, well, it doesn't really fit what we're doing at all. So let's punt and come up with that XY chart and see if that can help us. All right, so let's start out by putting this first number that's on here. It's 4 and a 3, and let's graph that point. So we're going to need an XY pair, right? So it's 4, 3. Alrighty. So we come over here. Let's I'm going to do my XY coordinate pair. So XY axes. And I'm going to come over here and I'm going to go to 4 and up to 3. And I'm going to put a point there. So Now, what do we mean by the vertical line going through that point? Well, that vertical line through that point, it goes straight up and down, right? Now, notice this point's on that line, assuming I can actually draw a vertical line, okay? That point's on the line. Well, what's the coordinates of that point? That's a 4 and a 0. That's certainly on that vertical line. What about this point down here? I don't know, maybe it's at -2. So what is its coordinates? Well, it's 4 over and -2 down. So 4, -2 is on that line too, right? So one of the things that we can observe here is that no matter what the y was, all of these have an x that's 4. So we actually use that to write the equation of a vertical line. All we say in this case is that x has to equal 4. And so for a vertical line, we don't make any risk. We forget all about the point-slope equation of a line. We forget about the slope-intercept because there's no slope. We can't use any of this structure that we built today. We have to go with a whole different approach and just specify the constraint. The constraint is that x has to equal 4. Y can be anything you want. There's no dependence between x and y here. We just have a rule on x. X has to equal 4. So in this case, the equation of a vertical line is an exception to the rest of all the lines. But you don't want to mess it up. Right? So it, remember, has any amount of rise over 0 run. When you divide any number by 0, the slope, that fraction doesn't exist, and that's why the slope doesn't exist. Okay, so hopefully that will be, hopefully you followed everything I did today. You can, of course, pause, rewind, and work on the delta math problems related to this.